In this chapter, we focus on one of the most important questions in front-end planning: why does this project need to exist? Before a project becomes drawings, estimates, schedules, contracts, or construction activities, it begins with a need. That need may come from a hospital requiring more treatment capacity, a university needing additional laboratory space, a manufacturer expanding production, or a public agency replacing aging infrastructure. But in each case, the building itself is not the starting point. The starting point is the business, operational, educational, or public service purpose the facility is expected to support. This chapter is organized around four major ideas. First, we define the owner's business need. Second, we translate that need into clear and measurable objectives. Third, we test feasibility and alternatives before committing to a preferred solution. And fourth, we align the project scope with budget, schedule, and long-term value. Together, these steps help ensure that the project is not only buildable, but also strategically justified. Every successful project begins with a purpose, not simply with a decision to build. A hospital may say it needs a new wing, but the real need may be increased patient capacity. A university may say it needs a new academic building, but the real need may be specialized instructional labs that support enrollment growth. A manufacturer may say it needs more space, but the real need may be higher production output or improved operational efficiency. This is why the project business case is so important. The business case documents the problem or opportunity that justifies the investment. It connects the proposed facility to the owner's larger strategy, mission, market position, service responsibility, or regulatory obligation. One key point is that the owner must define this need. Architects, engineers, contractors, and consultants can help test feasibility, develop options, and evaluate risks, but they cannot determine the owner's mission or strategic purpose. The table on this slide shows how weak planning statements can be improved. A weak need statement might simply say, "We need a new building." A stronger statement explains that existing labs cannot support projected enrollment growth or current safety requirements. That difference matters. A vague statement invites different interpretations. A stronger statement gives the project team a shared basis for decision-making. So, in front-end planning, the first task is not to ask, "What should we design?" The first task is to ask, "What problem are we trying to solve, and why does it matter?" Once the business need is defined, the next step is to translate that need into clear project objectives. The business need explains why the project exists. The objectives explain what the project must accomplish. A project objective statement helps turn broad strategy into practical decision criteria. It should address issues such as required capacity, performance expectations, budget limits, schedule requirements, quality standards, operational needs, and long-term value. The SMART framework can be useful here because it encourages objectives that are specific, measurable, achievable, relevant, and time-bound. But the real value of SMART objectives is not paperwork. The value is better decision-making. For example, "The campus needs more space" is too broad. A stronger objective would be, "Provide 45,000 square feet by fall 2028 for construction management and engineering programs." "The hospital is too crowded" becomes stronger when it is translated into, "Increase outpatient capacity by 20% while maintaining adjacent clinical operations." And "The plant must expand" becomes more useful when the objective states that the project must add a process line capable of producing 30,000 additional units per month while meeting the owner's target return. Clear objectives also help the team resolve conflicts. If cost, schedule, quality, safety, performance, and long-term value are not prioritized, decisions may become subjective. But when the owner's priorities are clear, the team can evaluate trade-offs consistently. This is what alignment means in front-end planning. Different participants may have different expertise, but they are all working toward the same definition of project success. After the need and objectives are defined, the team must test whether the project is feasible and whether the proposed solution is actually the best response. Front-end planning should not begin with one preferred design and then look for reasons to justify it. Instead, it should begin with a disciplined evaluation of alternatives. A feasibility study examines the project from several perspectives. Strategically, the team asks whether the project supports the owner's mission. Technically, it asks whether the facility can be designed and built with available technology, site conditions, utilities, labor, and materials. Financially, the team evaluates whether the expected benefits justify both capital and operating costs. Operationally, it asks whether the owner can staff, operate, and maintain the facility after completion. And from a legal or regulatory perspective, the team examines whether approvals, permits, zoning, and environmental requirements can be satisfied within the needed timeframe. The do-nothing option can also be valuable. It gives the owner a baseline for understanding the cost and risk of inaction. Sometimes doing nothing may lead to lost revenue, reduced service capacity, safety risks, or regulatory penalties. In other cases, it may show that a major capital project is not yet justified. The outcome of feasibility analysis should support stage gate decisions. A go decision means the project is ready to move forward. A rework decision means the concept has promise, but the information is not mature enough. A hold or no-go decision means the project should pause or stop. And this is important. A no-go decision is not a failure. In many cases, it may be one of the most valuable outcomes of front-end planning because it prevents the owner from investing major capital in the wrong project. Once a preferred alternative is selected, the team must keep the developing scope aligned with the authorized budget, required schedule, and long-term value expectations. Scope, cost, time, and value are always connected. A larger scope usually requires more money or more time. A shorter schedule may require premium labor, early procurement, or reduced flexibility. A lower first cost solution may create higher operating and maintenance costs later. Front-end planning is the best time to evaluate these trade-offs because the project is still flexible. Before design is fixed and before procurement or construction commitments are made, the owner has more room to make thoughtful decisions. Two important tools in this process are value engineering and life cycle cost analysis. Value engineering should not be treated as a late-stage cost-cutting exercise. In front-end planning, it should be used to preserve or improve required function at the best overall value. Life cycle cost analysis looks beyond the initial construction cost. It considers the total cost of ownership, including energy use, maintenance, replacement, downtime, and long-term operational performance. This is why operations and maintenance personnel should be involved early. This slide also warns against project first, purpose later thinking. That happens when an organization becomes attached to a building, site, or design concept before confirming the actual need and testing alternatives. The better sequence is purpose-driven. Define the need, set objectives, evaluate alternatives, select the concept, align the scope, and then authorize the next phase. In other words, strong front-end planning helps the team move from enthusiasm to evidence before major commitments are made. This case study shows how strategic alignment can change the direction of a project. A public university initially considered building a new health sciences facility near the center of campus. The idea was attractive because it was visible and politically appealing. But before moving directly into design, the university used front-end planning to clarify the real problem. The team discovered that the main issue was not general classroom space. The real need was a shortage of simulation laboratories, clinical skills rooms, equipment storage, and flexible interprofessional learning areas. The existing building also had outdated mechanical systems and limited capacity for future technology upgrades. Once the real need was defined, the team created clearer objectives. The project had to support 25% enrollment growth over 10 years, allow phased occupancy before the academic year, and remain within a funding plan that included state funds, donor support, and university reserves. The owner also clarified its priorities. Program functionality and schedule certainty were more important than highly customized architectural features. The team evaluated three alternatives. Renovating the existing building had the lowest initial cost, but it could not provide the required ceiling heights, mechanical capacity, or layout flexibility. A large new central campus facility was highly visible, but it created utility relocation problems, parking impacts, and circulation conflicts. The best option was a moderately sized new building on an edge of campus site, combined with selective renovation of the existing building. This option reduced disruption, provided the right infrastructure, allowed future expansion, and supported lower life cycle operating costs. The key lesson is that the team avoided the trap of designing the most visible concept first. By defining the need, testing alternatives, and aligning the selected scope with funding and schedule constraints, the university created a stronger business case and a more defensible basis for funding approval. That is the value of front-end planning. It helps owners make better decisions before commitment when the ability to influence outcomes is still high.